Participants in a study to evaluate the accuracy of lie detectors were divided into two groups, with one group reading true material, the other group reading false material while they were connected to a lie detector. This table below gives whether the participants were lying or telling the truth, and also whether they got picked up telling a lie by the lie detector. We're interested in determining if there's a difference in the proportion of times the lie detector says the person's lying, depending on whether they were lying or telling the truth. So the first thing we're asked is if the conditions are met for the two sample tests for proportions and to verify our answer. What we end up counting is the n times p hats for both of the groups and n times 1 minus p hats for both of the groups. What those end up being is the number of yeses and nos for each of the groups. And so we actually already have all those counts. The number of yeses for the first group is 31. The number of no's is 17. The number of yeses is 27. The number of no's is 21. So since these are all greater than or equal to 10, this would be the same as checking like n1 p1 hat, n1 times 1 minus p1 hat, and so on are all at least 10. And we could assume here then that we have independent groups and also that these are random samples. So the next thing we want to do is find the three sample proportions for the proportion of times the lie detector says the person's lying, which is the proportion for just the people lying, the proportion for the truthful people, and then the pooled proportion or overall proportion. So P1 hat will be the proportion for the lying people. So for the people lying, 31 yeses out of 48 people, giving a sample proportion for that group of 0.6458. We'll let the second group be the people not lying, 27 out of 48 for that group. So 0.5625. And then what we just call a common p-hat or a pooled p-hat is overall. So overall, we have the 31 plus 27 reports of a lie out of the 48 plus 48 total people. And so that is 0.6042. This pooled p-hat should always be between the other two p-hats. So you can see that 0.6042 is between 0.6458 and 0.5625. So we want to test to see if there's a difference in the proportion of times the lie detector says the person's lying, depending on whether they're lying or telling the truth. So we're going to test if the difference in proportions is 0, or you can also write that as P1 equal P2. And we're just trying to see if there's a difference. So our alternative hypothesis will be a not equal to 0 or P1 not equal P2. So this is a two-tailed test. The test stat Z for this test, since our conditions checked out, we can use a normal distribution. So we do our difference in our two sample values up top. And then in the bottom, we have the square root of, and down here we use this pooled value. So 0.60421 minus that over sample size 1 plus, and then again we use this pooled value. And then sample size 2, and those are both 48 here. So this comes out to be a test stat of 0.8345. So what we want to do is look that up in the normal distribution in StatKey, and we want to look in both tails, and that will give us our p-value. So we're going to be doubling whatever we get in one tail, so I'll get that jotted down. So if we go over to StatKey and we click on the Z, or normal, and then click on two-tail, and then our test stat goes at the bottom, and we'll put the positive side on. We had 0.8345. And so we can see we get 0.202 and 0.202 for both of those tails. So we're doubling that amount. So we have 2 times 0.202 or a p-value of 0.404. That is a large p-value, leading us to fail to reject our null. And then at this point, we'd want to write out the rest of our conclusion in words. So we would say something like, we do not have significant evidence of the alternative. So we do not have significant evidence that the proportion of times the lie detector reports the lie differs for those people lying and telling the truth.